if we invested $100,000 at 2% interest per year, compounded monthly, how much would we have in 30 years? What if the interest rate was 4%? What if it was 6%? So we know that the amount of money that we'll have is given by the principal times 1 plus r over n, the annual interest rate divided by the number of compounding periods per year, raised to the nt power, where n is the number of compounding periods per year, again, and t is the number of years. So here we can substitute in 100,000 for P. R is 0.02, N is 12, and then in the exponent we've got 12 for N times T, which is 30. And if we go through and do these calculations, we end up with $182,120.90 if we round to the nearest penny. All right, let's look at what happens if the interest rate is 4% or 6%. So if it's 4%, the only thing that's changing is that R is going to be 0.04. Everything else stays the same. And when we do this calculation, we end up with $339.80. So we end up with much, much more money if we have 4% interest instead of 2% interest. In fact, the amount that we earn on top of what we invested has much more than doubled, even though the interest rate has only doubled, and that's because it compounds. Let's do the last one now at 6% interest. The only thing that changes now is R is going to be 0.06. And when we make that change in our calculation, we end up with $602,257.52. So in this first problem, remember we started off with 100,000, and the amount that we ended up earning was about $80,000. In this example, we started with 100,000, but the amount that we earned was 500,000. The interest rate only tripled, but the amount of money was much more than tripled. If we look at 500,000 compared to 80,000, that is being multiplied by more than 6 times. So when we're looking at interest rates, if the interest rate is doubled, that doesn't mean that the total money we get will double. We're going to end up making much, much more money than that. So really, it's very important to compare interest rates, because a small change in interest rates over the course of a lifetime can end up being the price of a house, for example.